Here's a stoichiometry problem where we're asked to relate carbon dioxide to magnesium carbonate. We're given a balanced chemical equation, and what makes this especially easy is this is a 1:1:1 mole ratio. Now the amount of reagent that we're given is in grams, and we know to compare one chemical to another it must be done mole to mole, so we're going to have to do an initial conversion. Now magnesium carbonate has a formula weight equal to 84.32 grams per mole, and you can confirm that for yourself. We start with our measured number and its unit. And we need to convert that to moles so that we can compare it to another chemical. So we use our formula weight as a conversion factor. And this allows us to convert from grams to moles. Now that we have moles of our magnesium carbonate, we're going to need a mole-to-mole ratio from our balanced chemical equation. This is the easy one. It tells us every mole of magnesium carbonate is going to release 1 mole of carbon dioxide. So if we look at our units, we can see that our units of moles of magnesium carbonate cancel, and we have moles of carbon dioxide. We check back in with our equation, and we see that it's asking for amounts in grams. So we're going to need to use the formula weight to convert between moles of carbon dioxide and grams of carbon dioxide. Carbon dioxide has a formula weight equal to 44.01 grams per mole. I again invite you to confirm that that's the correct formula weight. So we want to cancel out units of moles of carbon dioxide. That means in this situation we need to multiply by the formula weight. Looking at our units, we see moles of carbon dioxide cancel. We have units of grams that survive. So our final answer, when we do the math that's indicated, will result in a calculator answer of 8.14227 grams. Let's look at our sig figs. We have 3 sig figs, 4. This is exact, so it does not impact the sig figs, and this has 4. Our least number of sig figs is 3, and we can write our final answer as 8.14 grams.